Welcome. We are SmartMaze, electrical and electronics engineering students from Kenyatta University.
I'm Rita Wawera.
Reinhard Rading.
I'm Anthony Mugirudi, and we want to show you how to automize kettle farming using the Intel Galileo.
Welcome.
Hi, welcome again. This is the controlling part of our project. We are trying to automize. We're simply trying to automize kettle farming using the Intel Galileo. As you know, earlier on, this is the Intel Galileo. It has a USB port, it has a power jack, and we are using 3 LEDs. We are using 4 10K resistors. We are using jumper wires, and these jumper wires, we have the black ones, and these are jumper wire, and this also jumper wire. The purpose for I not putting this jumper wire like the others, like this one, you see this there is a sensor here, but this sensor is covered. This sensor is simple, it's the same as this sensor, because that is why I removed this one, so that you could see this sensor and know that it's the same as this one. Beneath this sensor is another jumper wire. This wire, I decided that I'm tapping it from the under this cardboard. This is a cardboard. Now this wire is the one coming out through this hole. It is this wire. There is another wire. This wire also comes to this point. It also comes to this point. It comes like this way, and comes out from this black one. Now this wire picks the signal. It picks the signal from this point. The signal therefore is generated from the negative end and the positive end. In short, it's generated from the VCC. It passes through the 10K resistor so as not to short circuit, and it's grounded here. So this one simply picks the signal. After picking the signal has to be sensed by an analog pin. Now that is why I took different analog pins to different sections. Now this one is the section called the water point section. This one is the section 1. It is a grazing section, and this one a section 2. It's also a grazing section. And all these sections are covered by sensors. This is a sensor which I've not covered. This sensor works on a principle of pressure or force or weight. If a cow was walking, or cows are walking and they're stepping at it, or maybe they are applying force on it, they simply make it to get this analog pin. This is simply an analog pin. They'll make this analog pin to pick the signal from the point, which is this one. Now this is the point of the analog pin, which supplies all the 3 types of sensors. And you have to keep in mind that this is a very expensive type of sensor. It doesn't use radiations, which you know they are harmful to the health of people. So I think this type of sensors, if used by people, they are environmental friendly. So this is how it works. We have sensor number 0. This is the first sensor. We have sensor number 1. This is the second sensor, and we have sensor number 2, the third sensor. Now that I've showed you about this sensor, let me cover it up. Wow, it's covered like that. That's the sensor I'm talking about. We also have outputs. When the first sensor, which is A0, connected to analog 0, this is analog 0. This one is connected to analog 2. This one is connected to analog 1. When this analog 0 sensor is activated, it shows that there is motion, or there is presence of animals in the first section of our project. And this is the water point. And therefore, if there is motion at the water point, the first LED will light. This LED showing the water point. This LED will light. Now, let us imagine that this is, I know you might laugh, this is a kettle. Now this kettle came and grazed at this point. What do you see? The first LED showing the presence of water point is blinking. That simply gives the person, gives the person or the guide or the person, the guard who is looking after the kettle, a signal that the kettle is available at the water point. Now let us come to sensor number A1. This cow, after drinking water, it will come to graze at this section 1 and it will have to step at this place. What happens at our control? You'll notice that the second LED blinks. The second LED simply represents the section 1 part. Now let us go to the third part of our vegetation. If the cow moves to this point and steps at sensor number A2, you'll note by looking at the LCD, our section 2 LCD will light, showing that there is a presence of cattle in section 2. What about our codes? While looking at our codes, you notice that there is this serial monitor. The serial monitor, because there is no any signal detected, there is no any signal detected or any cow present at the points, it shows that there is no cattle at any point. Now, let me put cattle at the water point and look at the codes. You will note that difference. You will note that cattle are present at the water point. If you look at those codes clearly, you will realize that the code reads that cattle are at the water point. Now come and see the prototype of it. The rate at which the LED blinks is the same rate at which the output is given at the serial monitor, showing that there is presence of cattle at the water point. What if I take off that cattle from that point? Look at the codes. No LED lights and there is no cattle present at any point. Just by looking at the codes, I'm also putting it at section 2. Look at it for yourself. You will discover that it writes that there is cattle present at section 2, and that is simply our control or monitoring side of our project. I wish that I hope that you are contented and you like it. Welcome to our second part of the project. We're trying to maintain security for the cattle while one is away. Now with the security part, we're having a security sensor. This is the security sensor, which works like the other sensors. In this security sensor of ours, we've connected the black wire. This black wire is the wire which brings about the signal, which collects the signal or provides the signal, because it's connected from negative to positive, from ground to positive, or from positive to ground by the means of resistor. Now, from there, we take the sensing part. This is our sensing part. The knob is our sensing part. We take the sensing part to A3. We take it to A3. To A3, as you're going to see from our. It's not A3, it's A4. From A4, as you are going to see from our codes in the laptop. Now we've connected our sensing part. This is the sensing part. It collects the signal from our signal provider. Our signal provider, I told you earlier on, is connected from the resistive part, which is grounded and connected to the VCC. We also have a ground. Of course, you have to ground your board. This part we're not using. This is a photoresistor, but we're not using this part as per now. And this is a buzzer. The buzzer will simply connect the black wire to the ground and the red wire to pin number 8. And as you're going to see in our in our codes. Now, this is what we were talking about. When you look at our codes, we are having int LED 2. This is where we connected our LED. And the buzzer, we have int buzzer 8. That is where we connected our buzzer. And our sensor, if you come down here, you'll see analog read A4. And exactly, if you come to the program, this one is A4, this one is A4, connecting our sensor. This one is pin number, this one is pin number 2, connecting our LED through a resistor. This one is pin number 2, this one is pin number 2, and this one is pin number 8, connecting the positive part of our buzzer to the buzzer and to the ground. We're not using this part. So it works in the principle that this sensor of ours uses contact or pressure or force. When force is applied on it, or a person is walking and maybe it's at night and you happen to step on it, you'll complete this, or you'll make the sensor or the sensor part from the analog part to get the signal from the signal provider, and this one will send high to the Intel Galileo through the analog input, of which will make the alarm from the buzzer to be high and the LED will blink. And this is how what happens. For example, I'm a thief and I'm coming at night. Definitely I'll step here. You're a thief and you happen to step at, definitely you step at this point before you enter the house. You'll step at this point. After stepping at this point, you'll activate the analog input, our analog 4, by bringing up by sending the signal. Now, upon sending the signal, the LED will light and the buzzer will bring an alarm. Now, this will be simply to provide security for the kettle. Suppose a person came at night and stepped at that point, the buzzer will make that noise and that person will be caught, and that's the security part of our project. I'm going to introduce you to another part of our project, which is the monitoring part of our project.
So we're using Intel Galileo to control the level of water at the water point. This is a tank, so when there is when the water level is minimum, it allows the floater to detect it, and it sends a warning. The buzzer rings and tells the warning that the water level is low, to add some water. So here we connect the buzzer to the Intel Galileo, to the breadboard, and we'll use some 2 resistors, an LED, and a floater, the tank. So in the tank here, we have a floater connected to one wire across the tank, then another red wire connected to the port 3 of the Galileo. So the buzzer is connected to the ground of the breadboard, and one is connected to port 8 of the Intel Galileo. So we're gonna assume this part of the circuit, and we'll mostly consider on this side of the circuit. So mostly, let's assume this is the cow. If it drinks water until the water level is below the required amount, it will detect and sends a warning to the Galileo, to that person who controls the water. So here's the code that we wrote about here it is. So the Intel Galileo buzzer connected on the port 8, Then another one is connected on port 3. The tank is connected to port 3. A3, the A3 of the galileo. So we'll go to the serial port, serial monitor, and here is what is the output. So here it is. So you can see the water is present. Yeah, what is. So suppose the water level, what is present. Suppose we come here and release the water. You can see some water here. Suppose the water goes down. Below, we expect the buzzer to ring to show that the level of water has decreased, to alert the user that there is some water is needed by the cow. So let's wait some minutes. We expect the buzzer to ring twice, to beep twice. Alert. Let's see. Let's reduce some amount. Yeah. The water level is medium. Yeah. You see, the water level has decreased. And the buzzer is ringing to show us that water level warning.